Hey. Okay. So we'll begin shortly. Let's give everyone a couple of minutes to join in. We already have a few guests here. Welcome, Aman, Ben Grady, Harshika, Rishab, Yogesh. Welcome all. Let's give more people a chance to join in before we begin. Okay, I think we can start. So everyone who is with us now, welcome to Making Kubernetes dev-friendly with Komodor and Okteto. We'll introduce our speakers and let them take the stage, but first some housekeeping. So like I said, today's subject is making Kubernetes dev-friendly. So as all of you know, Kubernetes was forced on us several years ago. And as the years go by, it's becoming more and more prominent, eating up more and more of the world. And as developers, we are forced to own our apps end to end, but it's not as easy when you're when your app is running on Kubernetes under the hood. And Arsh from Okteto and Nir from Komodor will share their knowledge, share their experience, and teach you how to overcome those challenges. And if you don't know, Nir Stein, besides being a software engineer at Komodor, is also the main contributor to ValidCube, Komodor's first open source project. Arsh Sharma is a dev experience engineer from Okteto and a very prolific public speaker. You may have heard him before in some conference or talk. And together, we are going to discuss making Kubernetes dev-friendly. So without further ado, guys, take it away and show us what you've got.
Hey everyone. I think there's some echo. Hey everyone, thanks for joining. Udi, could you change the slide and we can get started? So before we begin talking about what we have, how we can make Kubernetes dev friendly, I think Udi's, yep. I wanted to give a bit of history lesson sort of about what has happened in the past and how we have reached this point where we currently are. So if you remember, like about 7-8 years ago, nobody was talking about microservices or containers that much. We all were coding monolithic applications which were running in infrastructure which we either owned in our own buildings or we rented out. But what problems started emerging from this approach was that scaling became very, very tough. Like as we sort of grew the code base and the users, managing this monolithic applications running in a data center became very tough. And this was something like we as an industry started struggling with. So the solution we came up to, for this problem was containers, and Docker popularized containers a lot. And the rise of containers basically led us to, break down these monoliths which we had written into microservices. So now, instead of the entire application being in one single code base on Git, we started breaking up different parts of the application, and different teams were responsible for different microservices. And what happened was that we started containerizing these microservices. So we no longer, relied on one single machine running all of this. Instead, we started leveraging the power of cloud remote machines and started accessing them. Then, to make things more easy, or let's say like complicated for developers, Kubernetes came into picture. And what Kubernetes did was it helped us run all of these containerized microservices at scale. Now, all of this happened, and with this, we changed the landscape in production significantly, right? We introduced new tools, we introduced new methodologies, CI/CD became different, we had staging environments and whatnot. Now, what all of this did was that it changed the world of developers. Developers who could earlier just work on their local machines now started facing a lot of problems. And the key reason we feel for this was that while the tooling and technologies upgraded in the production or DevOps landscape, the tools available for developers sort of did not improve at a same pace. So if we go to the next slide, I want to touch on some of the challenges which developers started facing since the shift happened. Udi, could you go to the next slide? So with this change, what happened was that the feedback loop became significantly longer. What this means is that now when we run apps in Kubernetes in production, that is very different from running a single microservices locally. So let's say you're a full stack developer and you're working on the front end right now. Running that front end locally and the results you're seeing aren't always going to be how they would look in production, because the production has changed a lot. So for this, you would have to rely on CI/CD jobs or access to staging environments. The problem with both of these approaches are that they are time consuming. For CI/CD to kick in, you have to commit your changes and wait for the CI to run all of its processes. Whereas for staging environments, you often in organizations, you have to like wait to get the access because someone else is running there, or in general, like the long story short is that as a developer now, earlier when you could just hit save and be confident that what you are seeing is what you will get, now that was no longer the case. The solution which got offered to developers for this was try to mimic that production Kubernetes configuration locally on your desktop. Use tools like Minikube, Kind, or whatnot. Now, this led to two main problems. First of all, developers were now, suddenly expected to know about Kubernetes just to go about their jobs of making applications and writing code. They had to keep up with the vast Kubernetes landscape of tools and everything, which is very complicated, I'm telling you. And second problem which happened was whenever developers had to write code, now they would have to do all of this additional configuration stuff and spend time, bringing up this infrastructure, playing with YAMLs, changing values, and all of that. So all of these lead to a very massive hit on productivity, and this leads to a very frustrating experience for developers who are just trying to ship new features and fix bugs, because something which was very simple earlier, which was as simple as just running your application in one command, writing code and hitting save, now became so complicated because the production landscape changed and the local development did not keep up with it. So these are a few challenges which plagued the world of developers, and I'll now hand it over to Neil to take it from here.
Yeah, thank you, Ash. Uli, can you click? Yeah. Cool. So as Ash mentioned, there's a big difference between the local environment and the production environment. And let's talk about why there is a difference between the local and the production. The main reason for that is that production is running on Kubernetes and your local environment probably running on some CLI commands, some makefiles, Docker Compose in the best case scenario, or even running your local environment on Kubernetes. This is like the perfect scenario. But still, if you have your local environment and production environment, both running in Kubernetes, there will still be differences between them. And what are those differences and how can we answer them? So the first difference that I can mention between the local and the production is that on local, I'm running on a single instance. I have a single server, and on production, I have multiple servers, replica sets. And why this make a difference? For example, if I have some cache, so the pods are distributed from each other and doesn't aware of the other pods. So if I want to share a cache, I need to share the cache across all the pods, and I can share it as a side container within the pod. It can be also some state. If I want to save a data to some storage, so I need to use some mechanism that help me to do it. So how Kubernetes achieve it? By using some stateful set, meaning that you define some volume. You can see on the right YAML, there is a stateful set YAML, and at the end, there is a volume claim when they define some volume, what is the permission to the volume, and what is the size. And now I can define some volume, and all the pods will go to the same amount, same volume. And now I can share a state across multiple replica. Second thing is that it's very common that you write your code on your local machine, and things work well. You test it, you validate it, someone doing a code review, everything is great. But you push it to production, the CI is passed, but now it's production and nothing's work. A very annoying scenario, and Kubernetes invented a solution for us. This invention called readiness and liveness probe. Readiness probes are there to determine if your container is ready to accept traffic, and liveness probe are there to determine if your container needs to be restarted. They are very simple. You just define some endpoint, some port, and just expose in your application that port in that endpoint. And then Kubernetes examine those endpoints and verify that everything okay, and looking for 200 status code. In that endpoint, you need to specify some, it can be some validation that your application is fine. It can be connection to the database. It can be some caching validation. It can be some business logic, whatever validate that your application is working properly. So I recommend to put always liveness and readiness probe across all of your applications. Udi, can you click? Great. Another thing to note when you're deploying any application, any workload, it can be daemon set, stateful set, deployment, whatever, to production, is note about the resources. When I'm doing something on my local machine, the resources is my computer, and I don't know if my application is consuming a lot of resources, a small amount of resources. I really don't know it. So a way to make sure that I'm not consuming too much resources are resources request limits, and those define the request of limits of the memory and the CPU. Two ways to see if you are on track on the usages of your resources is one to do profiling. Any standard APM offering a cool and new and very simple profiling. And the second way is to track on kubectl on Kubernetes native events. As you can see, like on the bottom screenshot, there is how you get the native event, just writing kubectl get events, and then you get all the events across all of your Kubernetes cluster. But if you want to get only the events of specific pod, you just do a describe and you see the pods, the events of this particular pod in the end of the usage. Second scenario is that you have missing dependencies between your local environment and production environment. Sometimes I have some packages or some CLIs that installed globally on my local environment, and when I'm running my application, everything works because they are installed on my machine. But when I deploy it to production, it doesn't include it in my image. So a very common and simple way to do it, and most of the companies does that, is to work on your local machine in Docker files, running containers instead of some CLI commands. And this will resolve it because this is like the basic same image within the local and within the production. The last thing that I think is very important to know when you are deploying to Kubernetes are the rollouts and how the rollout works. It's not switching between version A to version B by just clicking your fingers. It's not like that. There was a rollout procedure that is very easy in Komodor, in Kubernetes. Before Kubernetes it was very, very hard to do a rollout, but Kubernetes offers a very simple way called running updates that helps you to do a rollout from version A to version B. It does all the work for you. All you need to do is to specify the configuration that is suitable for your application. And this is basically determined by two configurations. One is max surge and the second is max unavailable. Basically, both of them means how much I want to do my rollout fast versus how much I want to do my rollout safely. So as a rule of thumb, I configure those both configuration to 32%, and the default is 25. And this is my 5 best practices how to avoid pitfalls from deploying local environment to production. Arsh, it's your stage.
Thanks for that, Neil. I'm gonna share my screen now. So could you stop staring yours? And like Neil just told you about the pitfalls developers run into when dealing with Kubernetes, I am going to show you how Okteto helps you combat some of these by making it easier for you to develop applications by simply developing on a Kubernetes cluster directly. So Okteto, basically what it does is it deploys your application to an actual Kubernetes cluster during development, and it allows you to code your applications there. So it's kind of like hot reloading for Kubernetes clusters, and we're going to see that in action. And we're going to understand how this improves the dev experience by following this story from a perspective of a developer. So let's say you're a full stack developer and your company has this movies rental application where you can go and rent movies. And you've been tasked with adding a promotional discount for KubeCon, which is coming up soon. And so for that, you have things which you need to manage. So as a developer now, if I have to work on, let's say, first adding a banner to this application, I need to bring up this application. Now, this is not simply an isolated front-end web page, right? This is a full-blown microservice application. So many microservices make it up. There's a backend, there are databases involved, and all that stuff. So as a developer, if I do not have access to a tool like Okteto, what I would have to do is locally create all of these and locally run all of these microservices on my local computer and bring each one of them up. Now, that is a very time-consuming task and load-consuming also for the local machine. But with Okteto, it's as simple as going to your Okteto dashboard, clicking Launch Dev Environment, and adding the URL for your repository. When you do the process for the first time, it takes like a couple of minutes. So I already did that before. But once you do that, you'll see that you have access to all of these endpoints for different microservices. Now, on the front-end endpoint, and which is why I'm seeing my application here, and you can see all of these microservices which make up our application have been deployed by Okteto. So let's see how you would begin developing with Okteto. You would clone this code for this application, and after that, open up your favorite editor. This is one of the other things I love about Okteto is how you can continue using the same tools you love. So any editor or any other preferred tool, you don't have to switch from that. Once you do that, you have to install the CLI tool called Okteto CLI, which is completely open source. And once you have that on your machine, all you need to do is run one single command, which is Okteto up. Once you run Okteto up, Okteto will connect to your cluster, and it will show you which one of your microservices you want to work on. So let's say as a developer, we first want to add that banner on the front end, which lets our users know that we are running a discount for KubeCon. So I'll select the front-end microservice. Now what is happening behind the scenes is that Okteto is replacing the container which is running in the cluster with a dev container. What's special about this dev container is that any code we will write now on a local machine, as you will just see, that when you hit save, that code will get transferred to the code running in that dev container. So there's a two-way file synchronization service, which allows you to write code and see the results of that code running live in the cluster. So this is what I meant when I said that with tools like Okteto, you can get instant and genuine feedback. Instant because it happens as soon as you hit save. You don't need to commit or wait for staging environments. And genuine because this is happening in an actual cluster, just like how your application would be running in production. So you see that now Okteto up is done. We have access to a terminal, which is in that container in the cluster. So just how you would be doing it locally, you first run yarn to install all the dependencies, and then you type yarn start to bring up your front end. And now if you see, you go back to your endpoint and see and hit refresh, you'll see that it is in development mode. Okay, so let's make a change on the front end and add that banner. I have already cheated and the code is already there. So we are just going to uncomment that and see what happens when we hit save. So I uncomment this, I hit save, I go back, and I see that a banner is here which shows me that there's a discount for users. So you saw how instantly, as soon as we hit save, this code we wrote got transferred to the code running in the cluster, and we were able to get feedback. Now, but if we see and try renting a movie, let's say a $13 movie, you'll see that the price is still the same. There is no 50% discount, which makes sense because we have only added this change on the front end, right? Now you have to work on the back end also. And now that would involve like bringing up, if you were not using Okteto, that would involve bringing up the database locally and doing all of that. But with Okteto, all you have to do is open up another terminal and type another Okteto up. And this will again list you all the microservices. And I know that the worker microservice, which is written in Go, is what is responsible for processing the price of our movie. So I run that up. And you can do this for any number of microservices which make up your application. So this way you can have your entire application up and choose to work on different parts of it easily without having to, configure anything. Like this application which is running right now, if you see on your Okteto dashboard, it uses MongoDB and it also uses Postgres, none of which are running on my local machine. Not only does this save resources, but it is also a very convenient way, and I can just get directly to the code writing phase. So once Okteto up is done launching a dev container into the service, let's change our code and actually add a discount. Now, I know that the code for this is in main.go, and again, I will uncomment this line, which reduces the price of the movies by 50%. Now, since this is like a Go application, you would have to like build it and run it. So I run make to build the application and build a binary for my application. And then I will run make start to actually run the application. So now if I go and hit refresh, you'll see that the price is reduced. And if we add like another movie, which is for $3, we'll see that the price is actually $1.5. So this was it for the demo of the Okteto platform. And Udi, you can share the screen again. But what I want you to take from this is that how convenient developing cloud native applications, which consist of like any number of like 10 to maybe even 20, 30 microservices it's a super easy process when you can bring all of that up in an actual Kubernetes cluster and see your changes as if they were actually running in production. So I'll now hand it over to Neil to show how Komodor also helps solve some of the problems which developers face when working on cloud native applications.
Thank you very much, Arsh. So now I will do some Komodor demo before I dive into the Komodor platform. Let's talk about what is Komodor and how to use it. So Komodor is a SaaS platform that helps you to troubleshoot and manage Kubernetes clusters. So how we basically do it, it's very simple. We have an agent that is installed on each one of the customer's cluster using just a simple helm command. Then the agent watching all the events that's happening on the cluster, reports them to the Komodor platform. Komodor process and ingests all of those events, and then backs them into the UI. So this is the Komodor platform. Here is like the main view of the application. Here is all these services, meaning all the workloads, daemons, deployments, rollouts, whatever, across all over my clusters. So here I can see like a full view of all of the clusters and all of the workloads. So as developer, I'm probably responsible for not a single service and not for all the services in the application. So I want to track only the services and the application that I'm as a developer is responsible for. So for that, we have some more zoom view that display only the services and only the application that is relevant for me. As you can see, this is the application view only for the backend developers. Here we can see like all the rollouts that happened, all the deployments that happened in the last day, all the issues that I had within the services, and what are the related Kubernetes resources to those applications, like nodes, ports, config map, secrets, PVC, and etc. So let's deep dive into some specific service. So here I can see some metadata and another data about my service. And I can see the timeline of what happened to the service. We need to remember that Kubernetes is stateless. It doesn't remember what happened in the past. It only knows what is happening right now or a few minutes ago. And Kubernetes is stateful. It does remember what happened in the past. So here we can see some timeline of that particular service in the last day, in the last 2 days, in the last week. I can say that timeline is specifically for that service, but if I'm a DevOps or some manager of the Kubernetes cluster, so I have the events tab that I want to show, but it shows you like not only specific workload events, but all the workloads, all the events of all the resources across all the clusters. So, but I'm a developer and this is what occurs. So this is an example of a rollout. Here we can see like the rollout changes. This is the Kubernetes changes. I increased my replicas from 3 to 6, changed some 2 annotations, changed some config map, and I can see also the changes that I made within GitHub or within any Git provider. Here, the developer just changed the YAML configuration. So I had a rollout, the rollout was successful, but I see that after a few minutes, I had a problem. This is called the availability issue, meaning my service was unavailable. As you can see, it's still happening right now. It's still open. I have only 1 of 6 replicas that is available. So if I deep dive into this specific availability issue, I can see like all the information that I need in order to investigate and see what is the problem. This is what Komodor suggests me. Komodor tells me, hey, maybe it is the problem. I can see the logs. I can see the events, as I said before, to track the events on those parts of this deployment. And if I want to deep dive even more into the pods, I can see all the pods that are related to this service and do some actions in order to troubleshoot, in order to see what is the problem, like opening some shell to the container and doing some commands. I can also delete the pod, doing describe everything that I could do if I use a kubectl. So once I know that I had some rollout, I had some problem. And now I want to see what is the problem. I see what is the problem, and now I have all the tools and all the capabilities to troubleshoot and solve the problem from end to end. And I think this is the real power of Komodor, to give you the context and the full image of the problem, and to lead you to the solution, and to give you the tools to solve the solution until the end. So this was it. I move the mic back to you, Arsh. Udi, can you share your screen?
So just to wrap things up, the key takeaway we wanted everyone to get from this webinar is that the tools in production have changed, and that it is about time we started investing in dev tools, or which are the tools available for developers to combat with this changing world of Kubernetes and containers. Because we as an industry have always agreed on the fact that like the local environment must match what's happening in production. And until we bridge that gap, it's going to be very tough for developers to deal with the challenges of Kubernetes. Tools like Okteto and Komodor help solve this problem because they speak a language which developers understand and help bridge that gap between development and the production Kubernetes setup. Thanks, and I'll give it back to Udi to conclude.
Thank you. Thank you. Okay, so before we wrap things up completely, we have one question that we haven't answered yet. So Nir and Arsh, you can each contribute an answer to this question by Faisal Farouk. The question is, being a beginner in this field, what would be your suggestion currently working on front end? So I'm guessing Faisal isn't working on Kubernetes yet. Any suggestions before we go?
I'm not really sure I understand what's being asked, but if you're working on front end, and if your app is just like a front end application, then are you asking about like any frameworks you should be using, or are you talking about how to scale this application? Because if you're talking about frameworks, then I think the popular choice right now is React. But if you're talking about like what you should do like to scale this application, then I would definitely advise that like if you feel like this is going to grow up into a big project, then you should invest in like containerizing this front-end microservice and looking into solutions which help you run that. It totally depends on what approach you want to take when you deploy this to production. Nee, do you have something you want to add to that?
Nothing.
Nothing.
Okay, nothing from Nir. I will just say that no matter where you are on your journey right now and what's your area of specific expertise currently, you can always transfer your skills. You can always learn new things, new frameworks, new languages. Even something as big and scary as Kubernetes can be learned.
There is, I think, another question.
Let's see if we have time for this. Yeah, why not? So just before we move on to the next question, so I just want to share a little secret about Nir. He started as a Unity developer. So he wasn't cloud native, wasn't born in the cloud like others. So he learned everything about Kubernetes in recent years, and you can too. It's possible. So one final question before we go. From Yuvraj. Hi, I'm a MERN stack developer. I am new to Dockers and Kubernetes. This session was quite great, and I got a fair idea of what Komodor and Okteto is doing. Oh, okay. So it's not a question, just a compliment to you two. So thank you.
We're glad you found the session useful, Yuvraj.
Can you elaborate, Yuvraj?
No, I was just saying that I'm happy to know that Yuvraj found the session useful. And
Yeah, and I'm sure it's not the only one. I found it useful, I will say that, and I think everyone who joined or will watch it or watch the recording later will learn something new. And this is an evolving field, a growing field. It's a question that a lot of really smart people around the world are scratching their heads and thinking how to make Kubernetes dev friendly. How can I enable my devs to own Kubernetes and not the other way around? So hopefully we gave, when I say we, I mean Nir and Arsh. I had very little contribution to this, but hopefully we gave people some food for thought. And you have, we will share the recording and the deck with everyone. You have our Twitter handles here, so feel free to reach out. We also have our Slack community, which you are all welcome to join and share other resources and events in there. And Arsh, any final words from the Okteto side?
Yes, I would advise. I see a question about like pricing, and you can, anyone who wants to know more about Okteto can visit okteto.com and explore the product for yourself. And if you have any questions regarding how to like make your journey to like using Okteto or anything or any help you need, you can reach out to us on community.okteto.com, which is our community, and you can ask questions there. If you have any feedback for this webinar or if you found it useful, just it would be great if you could let us know by making a post there, and I would really appreciate that. Thanks for watching.
Thanks, everyone. See you next time.
Thank you, everyone.
Bye-bye. Thanks, Nir and Arsh. Bye. Oh.